Alrighty, in today's lesson, we're going to be looking at 11.4, which is just basic matrix operations. All right, so the basics parts of this lesson, and of course, we'll get into some more examples, but you need to be able to do matrix addition. And matrix addition is super straightforward. You have to make sure the dimensions of both matrices are the same, and then you just add their corresponding elements. So to add two matrices, so A plus B, you would just add their corresponding elements. And that's it. But again, big note here, A and B must be the same size. So if you have a 2x3 matrix, it can be added to a 2x3 matrix. It cannot be added to a 3x2 matrix. They have to be this exact same size. All right, the other thing is scalar multiplication. In scalar multiplication, if there's a number outside the matrix, you simply just multiply to every element in the matrix. So if you have a scalar k, it is to be multiplied to each element. You need to be able to do matrix subtraction. And it's the same concept as matrix addition. To subtract A minus B, you just subtract their corresponding elements. Couple things to note. Matrix is commutative. A matrix addition, sorry. Meaning A plus B equals B plus A. Matrix subtraction is not commutative. Meaning A minus B will not equal B minus A. Now, there are certain situations where it can, but it's not every situation. All right, the next big stuff is to be able to matrix multiply. This is probably the hardest. In matrix multiplication, you are not multiplying each corresponding element. You're actually going to be multiplying row by column. So to multiply, you take row times, so basically take rows of A times columns of B. So to do an A times B here, this would basically be A11, A12, A21, A22 times B11, B12, B21, B22. And what you would do is you would take the row, oh, that's not a row. You would take the row of matrix A and multiply it to the column of matrix B and then add their products. So this will become A11 times B11 plus A12 times B21. And that would give you one element. Then you would take the first row times the second column. And now you would get A11, B12 plus A12 times B22. That would give you another element. Then you would take the second row and multiply to each independent column as well. So this would give you A21, B11 plus A22 times B21. That again would give you one element, and then take second row times second column, and then you would get A21, B12 plus A22 times B22, and then that would give you another column. With matrix multiplication, if this is an n by m, this must be an m by n. These outsides don't really matter, but these insides must be the same. If the inside dimensions are the same, then the outcome will be the outside dimensions. So for example, this 2 by 2 times a 2 by 2, these are the same. So therefore, this is how big my matrix should be. All right, this is just a square matrix times a square matrix, but that's the idea behind it. And then another big note here, matrix multiplication is not commutative, meaning A times B does not equal B times A. Right. So those are the big notes that are in 11.4. So let's get into examples. I will say in the homework, they make it really easy on what you are required to be able to do in this class. If you ever want to see it go a little bit further, I don't mind doing those type of examples, but for the sake of the class in this lecture video, I'm just going to show what's required of you. And then if you would like to see what the next step is, just let me know. I can make another video and send it to you. All right. So with that said, let's do some examples. Let's look at number 7 first. You are asked in 1 through 12 to use A, B, C, and D to determine the following if possible. So you are asked to find 2A plus 2B. So before I go to multiply this out, matrix A and matrix B must be the same size. And as I look at matrix A, it is 3, 1, 0, negative 2, 0, 5. Matrix B is 4, 3, negative 2, and then negative 5, 0, 2. I can see that this is a 3 by 2, and then this is a 3 by 2. So therefore, they're the exact same size, so I can add. To do this, I'm just going to write it out. So this is going to be 2 times matrix A, and then plus 2 times matrix B. So remember to multiply scalars. You just take the scalar and you multiply to every element. Now I'm going to draw these arrows, but I won't do it on this one. But you take that scalar and you multiply to every element. So this becomes 6, 2, 0, negative 4, 0, 10. And then do the same thing. So this then becomes 8, 6, negative 4, negative 10, 0, 4. Then you actually just now add their corresponding elements. So that means I'm going to take 6 plus 8, which is 14. I'll do 2 plus 6, which is 8. 0 plus negative 4, which is negative 4. Negative 4 plus negative 10, which is negative 14. 0 plus 0, which is 0. And then 10 plus 4, which is 14. And then there's your answer. All right. So not too complicated on the math. Let's do another one. Let's do number 11. This one is 4A minus 3D. All right, let's look at this. So A, again, was 3, 1, 0, negative 2, 0, 5. And D is 3, 2, 5, negative 2, negative 4, 1. So this is a 3 by 2, and this is a 2 by 3. These are not the exact same dimensions, so therefore this is not possible. So again, make sure that the dimensions are exactly the same before you get into the work to see if you can even add or subtract. All right, so I want to make sure I show you one of those. So let's look at another one. So let's look at number 15. In the next set, you're asked to determine the values of the variables that will make the following equations true. So number 15 gives you A, 2B, C plus 3A, 2, negative C, and you are told it's equal to 8, 2, and 2. All right, the way this works, I'm going to take this element plus 3 times this element. So that would give me A plus 3 times A, which is 3A. And then I know it's equal to 8. So now I have an equation. So A plus 3A is 4A equals 8. Divide by 4. So A is equal to 2. Do the same thing with the next one. I'll take 2B plus 3 times 2. So that's going to be 6 equals 2. So then I solve this one. This gives me 2B equals negative 4, and then divide by 2. So B equals negative 2. And then do the same thing with the last one. C plus 3 times negative C. So that's going to be C plus 3 times negative C would be negative 3C. And we know it equals 2. So C minus 3C would actually be negative 2C. And then I would divide by negative 2. So C would be negative 1. So there you go. And this isn't really a coordinate. So you can just leave it as A equals 2, B equals negative 2, and C equals negative 1. All right, so that's how this process is. So let's look at another one to give you another example. All right, this is number 17. You are given 3x 2y plus x negative y z equals 402. So if we backtrack a little bit, this right here is actually a 1 by 3, and this was a 1 by 3. Same dimensions, so I can add. If you look at this one, this is actually a 2 by 1, and this is a 3 by 1. Not the same dimension, so I couldn't even solve it if I wanted to. So this is not possible. Again, trying to give you an example of what to look out for. All right, this next set is actually super easy of what you're required to do, which I was really thrown off. I was like, this could be real good practice, but either way, I'll show you what you are required to do. So number 27, you're asked to evaluate the following matrices if possible, but on the homework, you're just asked to figure out what the dimensions of the answer will be. So let's look at them. So number 27, you're given 3, negative 2, 1. And then you're given 5, 0, 9, negative 1, 3, 4. So this is a 1 row by 3 columns. This is a 3 row by 2 columns. To be able to multiply, these must be the same, which they are. And then the outside would be your dimensions. So again, the homework does not ask you to actually multiply. It just asks you to do the dimensions. But I'm just going to verify that just real quick. I'd hate to do all these and it not. In 1 second. And when I was doing it, that's all that I saw on there. All right, so let's see. Okay, I see. Okay, then it does ask for the answer. All right, good. All right, so there is more to it. You have to figure out the dimensions and then do the math. All right, just want to make sure. So I'm glad I checked. All right, so now that we know we can do it and we know what our answer will be, remember it's going to be row times column. All right, so in this case, I do 3 times 5, which is 15. Again, I'm supposed to have one row with 2 columns, so this is going to be 15, plus -2 times 0, which is 0, plus 1 times 9, which is 9. That would give me my first element. Then I take the first row times the second column. So 3 times -1 would give me -3. -2 times 3 would give me -6. And then 1 times 4 gives me 4. So when I work this out, 15 plus 0 plus 9 gives me 24. And then -3 minus 6 is -9. -9 plus 4 gives me -5. So there's your answer. All right, so I'm glad I did check. So then once you determine it can be done, then you just work it out. So let's do a few of these. I was curious. I thought that was going to be way too easy. So again, number 29 is what we're looking at. All right, so this is a 1 row by 2 columns, and this is a 2 row by 2 columns. These are the same, so my answer must be a 1 by 2. So now I'm ready to work it out. So this is my row times column. So 3 times 0 is 0. 7 times 5 is 35. And then row times column again. So 3 times -8 is -24. 7 times 6 is 42. So in this case, this would give me 35. And then -24 plus 42 gives you 18. All right. So let's do another one. Let's look at number 30. All right, number 30 is a 5, 0, -3 times a 4, 2, -6. So this right here is well, let's go back to the same color. This is a 1 row by 3 columns, and this is a 3 row by 1 column. So these are the same, and my outcome will be a 1 by 1. All right. When I do that, it's basically this row times this column, and I'll be left with one answer. So 5 times 4 is 20. 0 times 2 is 0. -3 times -6 is 18. So 20 plus 18, my answer would be 38. All right. Let's look at number 31. Number 31 is presented to you as 3, 0, 5, 9, 0, -2, -4, 2, 7 times 3, 2, 2, 1. So this is a 3 row by 3 column, and this is a 2 row by 2 column. These are not the same, so therefore this will not be possible. All right. Let's look at one more of this, and I'll do a different one as well. So this is number 32. So you are given a 4, a 2, a -6, and a 5, a 0, a -3. So this is a 3 row by 1 column, and this is a 1 row by 3 columns. These are the same, and you'll be left with a 3 by 3. So when we work this out, I would take this row times this column. So 4 times 5 would give me 20. So first row, first column. First row, second column. So 4 times 0 is 0. First row, third column. So notice the row and the column that I take is in its corresponding element as well. So 4 times -3 would give me -12. Now I move on to second row, first column. 2 times 5 is 10. 2 times 0 is 0 for second row, second column. Second row, third column. 2 times -3 gives me -6. Now you're going to take your Third row, first column, -6 times 5 is -30. Third row, second column, -6 times 0 is 0. Third row, third column, -6 times -3, +18. So I'm then with the result of a 3 by 3. All right, so I just got one more that they give you to make it tricky. Let's look at number 47. 47 is given to you as B times D times A. And we are given that A is a -3, 2, 1, 3. B is a 8, -5. And D, because I don't need C for this example, is -5, -1, 4, -1. So before we actually do all the math, let's just make sure it works out. So B is a 1 row, 2 column. D is a 2 row by 2 column. And then A is a 2 row by 2 column. So I have to do the inside first. So these have to be the same, and they are. And then I'm left with a 1 by 2 times a 2 by 2. And I see that these are the same. And therefore, my answer would be a 1 by 2. So I now know that what my outcome will be, and I know that there will be an outcome. So now I can do the math. So I start with the B times D first, because that's the order of operations. So this will be 8, -5 times -5, -1, 4, -1. So I take row by column, because I'm supposed to be left with a 1 by 2. So 8 times -5, that's -40. -5 times -1 is a +5. So 1 row, 2 columns. So then first row, second column. So 8 times 4 would give me 32. -5 times -1 gives me a +5. So my outcome here would be a -35 and a 37. This is the outcome I'll use to multiply A. So this is going to be this outcome times A. So it has to be in this order. So I'm going to go -35, 37, and then times -3, 2, 1, 3. Again, I saw a 1 by 2 times a 2 by 2 gives me a 1 by 2 as my outcome. So this will be first row times first column. So -35 times 3, what's that? 7105. So that's a +105. And then 37 times 2, what's that? 74. And then first row, second column, -35 times 1 is -35. 37 times 3, is that it's 105, then 2, 4, 6, 111. And then we just work this out. So then 105 plus 74 gives me 179. And 35 plus 111, that's going to be 2476. Perfect. There you go. And so that's how you do something like that. That's pretty much all that you're required to do. And of course, if you need more examples, please reach out and let me know. Until the next video.